Okay, I think we are good. So what I'm saying is, so right, so this is the pattern which I've used. So based on the index positions I and J, I try to first of all I was trying to do something else here, but I then realized there is no pattern here which could be used. So I then moved to look like if there is any other pattern to use, and because this is not working. So this seemed to be working. So I use this and try to provide a solution here. Uh,
At first, I also started doing that if else thing.
hmm,
But when I started writing it, I realized that it's not scalable.
right.
Uh, so then I thought of a different approach.
No,
Let's
this
make
is
it
great.
generic.
Great,
Mm.
great. But try to do it this time without using an array.
Sure, sure.
Because what will happen in that case, right? You would be challenged to print the value as soon as you are finding it. Right?
Mm.
You are currently storing it, right? And
Right,
then because of the array, you get the opportunity to store it somewhere, right? And you can play
right,
with the numbers. But if you
right.
try to print this as is as you're
Mm-hmm.
processing it, you would have to maybe have to use some other approach also.
Mm.
Okay. So it would really add some more dimensions to your understanding.
Sure, sure.
Right? Okay, great.
Thank you.
Okay, I'm sure not my solution is not the most efficient one. I'm very sure, but again, this is one of the solutions which people can use. And I've tried to make things very, I mean, comprehensible here. But yeah, please, if anyone needs any clarity on it, they can ask me on these patterns, right? So, and the assignment, I have also added the assignments PDF here in this Java to April branch, and all the questions are there in the Java assignment one Java file. Okay, but I mean, saying very specifically, right? This is I was happy to see like almost everyone was able to. I mean, who all have submitted, right? They were able to do these assignments, and they at least attempted it, right? Whatever way they did, I don't care, right? There are hundreds of different ways to achieve things, so which is fine. Ultimately, your code should work first of all, right? First, if you don't know how to make a problem solved, right? It does not matter how many concepts you learn. You have to first uh, find the first way to solve the solution. If you're done with it, then try to improve yourself on the second approach. Okay, and people who have not started, this is for them. Please do that, right, and then you can evaluate yourself like where you are. Okay, one thing which I wanted to specify for Rafael, right? I don't know, like Rafael, if you have done something extra on it, but the way I see this branch as of now, I would want to just understand, like, if you want to, like, if I see your reverse number, right, this part, see, you have used this approach, right, this here, like you're trying to find the tens and the ones here, and then you're trying to do all of this. Like, do you now understand that? See, first of all, I did not try to run it, but just tell me, did it work for you? If you run it, are you able to print the reverse value? Okay, great, great. So then you at least you know the first way, right, of how things can work. But I was very happy to see that you are thinking, you're trying to think in a lot of different directions, right? Because how you used it, you yourself created some of the methods there, right, which can help you to achieve the different things there. But what are you also trying to do is you're trying to reinvent the wheel, right, which is not required. But I was very happy to see that you were able to think in that direction, right? But again, I would suggest you again, please reattempt this question, okay? And you can refer to the because this is all not required to find the number of digits, right? You need to know how can you find a number of digits in a number. How do you do it, right? What you can do is you can take a number, keep dividing it by 10, right? And then whatever and how many times you divided that number to receive the zero value, right? It will give you the number of counts of the digits. Okay, so it helps you in that way, right? Similarly, if you want to I mean use the remainder value and all, right, you have to use similar approach. Please refer to the assignments of anyone, right, and then you can get to know. uh, Divisor, right? Divisor is almost, you also did it correctly, so there is no concern around it. So this is absolutely fine which you did, right? One thing, right, which I wanted to mention it to everyone, right? We all did in a this way only, right? We started with one and we are checking it till the number of 35 here, right? If you talk about divisors are those numbers which can help, which can divide your number, right? And you get the remainder as zero, right? That is what a divisor is. So if you divide 35 by, let's say this is a odd number, let's take an even number 34, right? If you divide 34 by a half of it, so half of 34 is what, 17. So what you need to do is you can just, and if you divide 34 by 17 you get 2, right? What if you divide 35 by 34 by 18, a number after the half part, 18, 19, 20, 21 till 35, will it divide it? It will not divide, right? It will not divide. So there is no need even to calculate, to use, to run your loop till that 35, right? What you can do is you can simply use it till num by 2. So in this way you are reducing your number of operations, right? Again, I'm not saying that this is the only efficient thing which you could do. Again, this is valid for everyone, right? Not just for the failure. This is valid for everyone. So you can look for such things, right, in your program, like how can you make it more efficient, how can you help here to reduce the number of iterations which your for loops can generate. If you can do it, please try to do achieve that also. Okay. Okay, great. Equilateral triangle, I think, almost everyone did it correctly. uh, but I hope that when you were solving it you understood like equilateral triangle like this, right? What do we, whatever the terminology of maths is, I don't know, isolation or what, but oh, where it went. Oh, we do not have it. Okay, matrix number.
It was equilateral, I believe. I named it isosceles.
Okay. Okay, no worries, no worries. Matrix number pattern. Okay, let me
But
open this up.
equilateral is also isosceles, by the way.
Okay, again, this part, right? This part again, if you would compare to my thing, right? Not just for Raphaelia, for everyone again. What I did was I I tried to find a solution. Let's say this one, right? So the third question was like of a Christmas tree. The let's say the vertical Christmas tree, the standing in the right way. Let's say I slanted it right, and now it is in a sleeping mode. So then it becomes a like a horizontal Christmas tree. So I named it as Christmas tree here. So if you would see this part here, right? See my number of, see the code, right, which I have written here, right? I've used for loop here and then a for loop and then these kind of for loops, right? So Raphaelia, if you would check yours, right, you are using first of all, right, you're using if else condition. I think you can avoid them and try to use the for loop, right? Although you are using it, but I think you are trying to solve it in a single go, right? Like the complete pattern in a single go. But I think if you would try to solve it in an approach like this, what you can do is divide your entire thing. See here what I did. If you would see this, this is the pattern, right? This is the Christmas tree, like in a sleeping mode, right? So if you would see this, it's a sleeping tree or a equilateral triangle, whatever you could say, but in that way, right? Now, what I'm saying is, in this approach, right? See how we can go, how we can print any pattern. We have to understand that the only way possible for us to print a pattern is that we have to go row wise, right? We have to first start with a row and then we can go to a column, right? That is what we do using the for loops or nested for loops, whatever that approach those are, right? But in those cases, right, here if you see this, right, it would become very difficult if you try to solve it in a single for loop, right? But what I thought to do is like I can break it into a upper pattern, right? All this case, because this is simple, right? This pattern, if I tell you to only print upper pattern, you know how to print it, because it's just like, it is like row is one, column is one, row is two, column is two. So it's a very simple pattern, right? You use two nested for loops and you start doing it, right? That is how you do it. Now for the lower pattern also it is very easy. There are four rows and four columns, right? It also becomes easy. You just start with the for loop but you start in the reverse order. You start I equals to 4 and keep reducing the number till you receive value 0, right? And if you print everything together, you get a tree like this. Okay, please attempt it again using that approach. Attempt this question with that approach, right, which I just explained. And do one more thing about this thing, right? So I think we are clear with the first part, right? That I just told you. Again, you can see like what I'm doing. And regarding the concepts of the division, right? Even I had to go back and see the net, like what are the terminology. So divisor is a number who divides, right? Number which you are dividing is called dividend. The remainder which you receive after the complete thing is the remainder part, and the multiple part is also called as quotient. Okay, so these are all the things, right? Again, I'm not saying that you have to learn this, but try to understand if someone asks you a question, right, or let's say problem statement in your interview questions. There they can use these things, these words, right? So there you may be required to know like what these are. Okay, and but again, you will understand all of this if you do and practice more, right, about things. Okay, similarly for you, you have solved three questions, which is great. Regarding the next two, right, I think now if you try to look at the solution, or if you follow what I just mentioned, right, you should be able to solve this also. Okay, the fourth and the fifth question. Try
I'll
to
refer.
just print the upper pattern first, right? Once you get that, then try to print the lower pattern, and then you have to understand that you need to just merge them together. Okay, print one after another. If you do it, you get that pattern. And for this, you have to work on the positions here, right? Okay, and I think everyone else is fine, right? I mean all the things which I saw, I'm pretty fine with it. I don't have a concern. Okay, great. But if anyone has a specific question or something, please feel free to ask. And all the code is the code my code is pushed to the repo. Someone wants to refer, please refer. I think I can make this a better one. This is not in a generic way right now. I will try to improve on this and provide a generic one, which like the one which Atul has provided, which is the right way to do things. So please follow that, and I will also try to provide a generic solution here, so that if you give any number here, it can print the value accordingly. Okay, let's start with our today's agenda. So our today's agenda is we have to discuss polymorphism, right? The one of the other OOPS concept, okay, in Java. So let's start. Recent project Java demo. This window. Just give me a sec. Okay, so let's start today's work. We are on which branch? We are on day 15. Let me change it to today's branch, which is get checkout minus B day 16. And today
Just
we are
a
going to
suggestion, Akhil.
yeah, yeah, please.
On the bottom right corner also you get to see the branch name of the IntelliJ.
Okay. Right, right, right. Thank you.
Most
Yes,
welcome.
right. So check out minus BDF 16, and I think we're good. Okay, let me just remove everything. Delete, delete all this, and our code looks clean. And let me write the agenda for today. Okay, there are so many windows open. Let me close all of them. What is this? This code also. Let me close. Okay. Okay. Regarding the next assignment, please expect tomorrow. I will provide a next assignment. This time, the assignment would be covering. I would try to give you a design. Okay, I will try to give you a design in the form of a diagram, and I would expect you to draw me. I mean, write the code for it in the form of creating classes let's say I will give you a model where a employee needs to interact with the organization, and there is a text department, and right, so you have to understand yourself like how you can make them I mean interactable, right? And I would mention like what all methods I need there, right? And I will tell you like what is something which is private to them, right? And accordingly you have to make the changes. Okay, try to use all the things which we have done till now, which is about the access modifiers, the constructor part, the methods in the classes, right? And I would also just tell you like the what kind of behaviors I want in those methods. So try to design that program, right? That project in Java, and the all the concepts which you have learned till now, they are enough. Okay, I will try to incorporate arrays, strings, and all of this. And what else? Um, I think that should be fine, right? So all of this you have to do, okay? But it would be a good exercise for everyone just to play around with classes and to know like how to interact with each other, right? And how to run those things. So next assignment would be on that area. Okay, so I am trying to complete it by tomorrow and share it with everyone. Okay, let's start today thing. And those who would have missed some classes or who were not part of it, please you can still try to attempt it based on your current knowledge. And again, if you are struggling with something, you have the access to all the recordings. Please refer them. And in the recordings also, right? If you would have noticed, I have started mentioning in the name itself like what topics we have covered in that video. Okay, so it can give really help everyone to understand like if you have to look into some specific area, which video to look at. Okay, let's start. So today's session is we're going to talk about the another concept of OOPS, which is polymorphism. Now, this is a very simple thing, right? There is actually not much to cover here. When I say this, I would say like not much, not complex things to cover here because we have already covered a lot of things which are required here. So I think the understanding should be very straightforward now. But let's see. So let's first understand what is polymorphism. If you'll go at the literal meaning of it, right? Poly means many. Okay, poly means many, and morphism means shape. Okay, I believe this is what it means. Okay, many shape. Now what this polymorphism means, it means that a single thing, I mean something which can take multiple shapes. What does it mean? It means, let's say that there is one thing which can behave as different things based on the input it receives, right? Let me give you like a real time example. Let's say I'm talking about let's say a man. Okay, I'm talking about a man, and let's say that the same man can behave as a son, right? Right, if the input is given, let's say if the inputs from the parents is given, right, then the same person can act as a son. If the child of that person, right, interacts with that, then that same person will behave as a father, right? If the inputs are given, right, from the office, right, that same person acts as an employee, right? And again, if a friend is interacting with that person, right, that it becomes a friend, right? So the but what is entirely like the thing, right? There's only one thing, but based on the input it receives, right, it behaves differently. This is what polymorphism is. Okay, how do you achieve this in Java? It is okay to understand from what I said in the real time example, right? That there's a single person, right? There's a single person, this, and if this receives an input from a parent, I mean let's say parents from, right, so this will behave as a son, right? If this receives an input from their his own child, right, then he will start behaving as a father, right? Similarly, if the employer, right, he is interacting with the employer, he will behave as a employee, right? And if a friend is talking to him, he will act as a friend, right? So this is what polymorphism is: a someone who can behave as different things, right, based on the inputs it's received, right? This is what polymorphism is. Now how does it translates in Java program, right? There are two concepts which we have to know about. The two concepts are, second, Okay. So, Abhishek, what I was saying, yes, there are two concepts here, right? The two concepts are with the name as overloading, and the second is overriding. This overriding part, right? For this to understand, right, you also require to understand about inheritance, right? That's why I covered inheritance first. Okay. So we have already covered inheritance, so this should be very clear now. Okay, but we'll cover it. And for overloading, this is like a thing over there. But what are these, right? What we are talking about here? See, both these concepts over here, right, are applied on methods. Okay, are both applied on methods. Okay. Now let's see what really they are. Let's say, let me think actually. Okay, let's say that I have a calculator class. I have a calculator class, and I have a method here which is public. Let's say it should return int value. Let's say, and it should do some addition. Okay. Now, for performing an addition, let's say one of the inputs which I've defined here is I need to, let's say, provide two inputs here. Let's say I will say int a and int b. Let's say I want to perform this, right? I want to add 3 plus 2. So this is the method for me, right? What if I want to add a decimal value? What can I do? What can I do, right? In that case, again, I can accept here also the float value, but you will have to then care of about the conversion, right? The casting part. You will have to do it. Okay, you will have to do that. So what you need to do is, uh, if I write another method, right, with the same thing, public int addition, and this time this method will accept two inputs, which would be of type what? Float. Now you can see here that the name of the method is same, addition and addition, right? But this method is accepting two inputs which are of type int and int. And this method over here is still accepting two inputs, but this time the inputs are of type float and float. Let's say there is another method, right? Addition, again the same thing, int and all. And here this is accepting three inputs. Let's say int a, int b, int c, right? And it will do the addition on three inputs here. But again, the name of the method is same, right? The name of the method is same. Let's say there is one more input. There is a one more method here, addition. And this time you are adding two strings together, let's say, right? So let concatenation part, right? So what you can do is you can accept string s1, string s2, right? Let's say I do a string or int, or not int here, let's say void, right? I will do this. Now try to see this, right? All these four methods are being written with the same name. Is it really allowed in Java that you can have multiple methods with the same name? Actually, it is not allowed, right? Unless and until you're trying to create an overloaded version of that same method. In this case, right, we have created four methods here, right, with the same thing. But the unique part with them is that the signature, right, the kind of inputs you are providing here, right, are differing, right? You can see here you are accepting two parameters and both are in, right? Here you're accepting two inputs again, but this time the parameters are of type float. Here you're accepting three inputs, but right, and the parameter is data type is in. Here you're accepting two inputs, and this time it is string. So if you have, see, if somehow you are able to provide, you're creating duplicate methods, but the kind of parameters you are providing there, right, are such that they result into a unique method being created, right? You can see, right, this is, I do not have a duplicate of this thing, right? I have not written a method which matches to this signature, right? You can see there is no such method. If you try to create one, it is not allowed, but you can still have a same name method, but then you have to just take care that the number of parameters right here, or the data type of them, should be in a way that they are unique from others, right? So if you do this way, right, this is called as method overloading. Okay, method overloading. This is called as method overloading. And now you can see that everything on this slide, right, is happening on the same class calculator, right? Let me show you this first, and then we'll talk about more rules around it. Let me create a class calculator. Okay, and here what I'll do is let me create a method public void addition. Okay, here I will accept two inputs. Let's say int a, int b, right? And I will do what? Let me do an int here, int. And if I try to do what? If I try to just return a plus b, right? So we are fine with it. It will work. Let me try to just copy this as is and try to add here. Let's see. Does my compiler complains? Yes, it complains, right? So you cannot have a duplicate method which is like it is. I mean, this is exact duplicate of this, right? You have the name as same, and you have this parameters or the arguments which you're accepting are also same, right? So it's a duplicate here. So Java will not allow. Okay, but Java does allow you to keep multiple methods with same name, but you have to just take care that the number of parameters or the type of parameters should vary, and they should be written in a way that they are unique from others. So if I do something like this, let's say I remove this, right? You see, it will not complain, right? You can see there, right? It will not complain. Let me just complete this return statement. Let's say return 0. You can see, right? I can now have two methods with the same name. So it works in Java. Let me do one more thing. Let me create another method of which will accept float a, float b. You can see here it still works. Here I have to return what? Float. Or if I want to return int only, what I can do? I can convert, I can cast my float value into int value. Can I do this? Okay, let me try if I can do this now. Okay, I cannot do this. Okay, I was thinking we can do this. No worries. Let me do it this way. Int c equals to a plus b. Okay, and let's convert this into int, right? And then why it is complaining? Required type is int provided float. Why I cannot do this? I can do this, right? And I can do return c. Okay, but try to understand. My focus was not on this. I was just trying to do this, but my focus was on this part, right? Now you can see, right? The names are same, but the argument types are different, right? Float and float. Let me keep it as float and int, right? See, it is different. But as soon as I will make this as also int, right, it will start complaining. It will say now this entire thing, right? At least this part matches to something which you already have in your class, which is this. So this is not allowed. Okay, right? You can have this way. So I hope you're getting the point, right? What is method overloading? Method overloading means that you can have multiple methods in your class with the same names, right? Provided that you keep the parameters, right? The arguments which your method accepts, right, are unique in a way, right? You can see those are unique. So this entire thing from addition to this is unique across the complete class. You will not Java will not allow you to have a similar thing in other method in the same class. Okay. Okay, let me do one more thing. So we talked about the name and this data type, which is okay. What about this return type? Let me do one thing. Can I just change the return type and think, and let's try to do one more thing. Let's try to do this. Instead of returning int, let me just return float. Okay, let me return float. And what I will do here is, I don't need to do this. I can just simply do float a plus b. Does it work? No, it does not work. So The proper rule, the must rule, right? The must rule is that Java does not care about this. Okay, your return type. It does not care about it. Whether you change this or you may change it, you may not change it. It does not. Does not impact your overloaded methods. But if you have not changed your if your this part, right, is not unique, then Java will not allow you to have such a method here. You can see this is matching to this, right? This is matching to this, right? And you may think, okay, the entire method is unique. Where the return type is different, let me make it private also, right? Let me make it private also. Now you may think, okay, this entire thing is unique in a way if I compare to this, but that is not how it works, right? It only compares the method name and the data type inside it, and the number of data types, number of parameters it accepts, right? So this thing should be unique. Okay, this thing should be unique. Okay, okay, let's move ahead. So this is not allowed. So what I need to do is, let me add something else here. Let me add int c. Now you can see it works fine, right? It does not complain now because this is unique as compared to other methods. Okay. Anyone has any question on this part? This is what method loading is. Method overloading is, right? Now you can see a single method like addition, right? Addition can behave like 5 different ways here. Okay. Either can addition can work 5 different ways. So if you provide two integer value, it will behave like this. If you provide it no value, right, it will behave like this. If you provide float and an int, it will behave like this, right? If you provided 3 inputs, right, it will behave like this, right? So it will behave like this. Okay. What I mean is, okay, let me just create another class. Let's say demo class. And here what I'll do is I'll create the main method. And now you see what I'll do is I will see calculator c1 equals to new calculator. Okay, c1 dot addition. You can see, right, all the different addition methods, right, which are applicable, which I can use, are shown here. I can see 3 addition methods here. Why only 3? I needed more, right? But if you would see, I have mentioned one of the method as private, so that's why I cannot see it here, right? Because it's a different class. So if I do c1 dot addition, I can see all 3 methods. So if let's say I do not want to provide, I want to choose a behavior where I don't have to provide any input. So you have to use this method, right? And then you can use it in your processing logic. This time, next time, I want a behavior. I want to use a method which can accept 2 inputs, and I want to see the behavior of it, right? So I will have to use this part, and I will provide 1 comma 2 here. Okay. And then there is another method c1 dot addition. Right here I want to use 3 inputs, 1, 2, 3, and 4. Okay, so this requires a float value. Let me provide one. This requires a float value, right? Okay, why it is complaining?
That should be in decimals, okay. 1.0 F.
1.0.
F.
Okay, no, it does not work. Let me just do one thing. If I try to create a variable here, let's say float f equals to 10f, right? And I use here f. Still does not work. What is the problem?
10.0 F?
Oh, I removed this. Okay. 10.0 f. Just a second, why it is having a problem here? If I comment this out, okay. Float int. Oh, you can see, right, what I'm trying to do here. My bad. Okay. I am trying to invoke this method, right? But it's a private method, right? So I cannot provide 3 inputs, right? So I'm trying to choose a addition method which accepts 3 inputs, which is not allowed, right? What is allowed is I can use something like this, right? You can see now it works, right? Because this time it refers to this method here, right, which is the public one. Private is anyhow not accessible, so I cannot use it here. So I cannot use a version of addition which can accept C inputs because my method is private, right? It's clear, right, everyone? Okay. Or no? Okay, let's see. Okay. So it says, right, so you can see, right, 10f works, 10.3 works. Let me see if 10 and comma 3 also works here. Even 10 did work, right? I don't know why, but it worked. Okay, great. So this is how it works, all of this, right? Now, what else? So this is method overloading, right? When you're working in the same class. I told you method overriding is something related to the concepts of inheritance. What does it mean? What I mean by that is that for overriding to work, right, you will require two classes at least. You will have a parent class and then you will have a child class. Okay, a child class. Now what you will do is, if in this case, right, you try to create a method here, let's say addition, and you say here int a, int b, right, and you create a method here. If in your child class you try to provide the same method with the same parameters, the name is also same and the parameter is also same, like this, addition int a, int b, right? Then what is happening here is, see, we learned from yesterday that using inheritance, right, what happens? Your child class gets all the things from your parent, right? So to try to understand, this child is also getting this method, right? So and so this child is also having this method here, plus this child also has this new method here, right? But both are same, right? Both are having the same signature. But I told you in the case of Java, right, it does not allow you to have method with the same name, right? But since one method is residing in a parent and the other same copy of it, right? I mean, the same, behavior, right, is also available in the child also. But these are two different classes. So in this case, Java does allow it, and this behavior is called as method overriding. Just try to understand the word overriding, right? It is like that you, let's take an example, right? Let's say that let's say your parents, right, have a business, right, have a manufacturing unit, and they have their own way of running the business, right, which is like from what they learned, right? So they have their own logic there. So let's say there is a method run business, and inside that method they have their own way of running the business. Now, since you are a child, right, you inherited everything which your father had, right, which your parents had. So you also inherited that business. Now, as part of it, you inherited that business, right, but you do not like the logic, right, the way your father or your parents were running that business. So what you will do now is, you will have the same method name, right, run business, but this time you will override the logic which your father had, and you will replace it with what you think is the right way. So what is happening in this way, right? Your parent, right, run business. So this is your parents, right? So you have a manufacturing unit, and your parent has that method run business, and they use their own logic to here, right, to run that business. Now when you inherited a thing, right, from your parent, you got the unit, and now as part of it you thought, okay, I will not run the business the way which my father ran. I will use some other approach. So but the name of the method would be remaining same, right? So you will have another method here within your child run business, but this time you will add your own logic, right? But in a way, what you're doing, you're trying to have a same method with the same data type, right? Whatever you may have, int or string, how many parameters there it could accept, but you will have an exact copy of it, right? But in this way, right, you see now what you have, right? Being a child here, right, you also possess that method here, right? You also inherited that method here, but you overrided the behavior of it by providing your own method. So now if you would run a method saying child dot run business, right, which version of business will run? This one or this one? It would run this one, right? Because you have overridden the behavior coming from your parent. That's why this concept is called as method overriding. You're overriding it, right? So child overrides the behavior which it is getting from its parent. Okay, let's try to do this. Calculator demo. Let me get another class. Let's say uh, what do we call that calculator, right? Which we use in our college days. Uh, I don't know.
Scientific calculator.
Scientific calculator. Yes. How can I forget? Scientific, scientific, right? Scientific calculator. Oh my goodness, it was a thing. Okay, great. Scientific calculator. Okay. So let's say scientific calculator. We designed a scientific calculator, and we want our basic calculator to be a parent of it, right? So scientific calculator is something which originated from a parent, right? From a calculator. So let me say extends calculator. Right. So let's do this. Now let me not create a method right now. Let me not create it. Let me simply say, if you would see here, right, it's a scientific calculator, it's a calculator. And if you would see, because this is a child of calculator, right, it will it will inherit all these public methods, right everyone, because of the rules of inheritance, except this private part, because private is something which is specific to that class. Okay, but all of the above public things, right, it still has access to. So even if I don't write a single line of code here, right, and if I go and try to create the instance of this class, scientific calculator, C1 equals to new, or let's not C1, C2. C2 equals to new scientific calculator in this, right? See this, C2 dot. You see, you're still getting all these methods, addition here, right? These are coming because of the rules of inheritance, right? There is nothing about polymorphism here. But let's see the power of polymorphism, right? What I will do is, what I will do this time is, I will try to change the logic of this version of addition. So what I will do is, I will write here using the same thing, right? I will write public int addition. Let me copy as is now, just a second. If I copy it as is, right, let me do this. Now you can see, right? See, earlier, right, let's say that I'm not adding anything. I told you, right, earlier, what is happening because of this line itself, that this scientific calculator will behave like these all three methods over here, right, are sitting, are already a part of this class, right? These are not visible here, but this is how it looks like, right? You can see, right? And we saw that, right? If you use this C2 dot here, you are able to see like what all methods were applicable, right? So in a way, these are already available here. And what I'm trying to say here is, so these three are already available. But I'm saying, okay, but override the behavior of a method here, right? So I use this thing, but this time I will do what? A plus B plus 10, let's say. Now, if I use scientific calculator dot addition now, right? Which version of code should run here? If I use if I pass 5 and 6 here, if I do this, you can see here C2 dot. You can see still only three methods are available. This one, the first one, the second one, third one. The second and third one are not, we have not created them here. They are coming from your parent thing, right? But the first one, you can see you have overridden it, right? You have overridden the behavior which was coming from the parent, right? Now what I'm saying is, if I'm doing this C2 dot addition, the first thing, and I say 5 comma 6, should it print 11, which is the behavior coming from the parent, or should it behavior, or should it print 21, which is the behavior coming from the child? Sally, you tell me what it should print. Sally, you there?
Yeah, but I'm not sure.
Okay, see what I told you is this is a child, right? And as a child, you have overrided the behavior, right, which is coming from your parent. So now, if you try to run that behavior, what should print it? It should print your version, right? It should behave as yours version. So in this case, this addition method here, right, over here, right, would behave as your method. I mean, the behavior which you have written. So it would print what 21, which is 5 plus 6 plus 10. Okay,
Yeah, yeah. Okay, okay.
okay. If you don't have this, right, let me just comment this out. Okay, let me first run this, right? Let's just run this and let's just okay. Right, let's run this and see the behavior. Okay, I'm not printing it.
But
Uh,
then why we did not commented it earlier?
which one? See, we are just creating the instance of the class, right? It does not mean that the class got removed from my code. The class still exists, right?
Yeah. No, no. The earlier part which you have commented right now, no. So earlier, why did not we commented it? Means, since I got confused with the two things, that's why I just asked.
Okay, let it be this way, right? Let us keep it this way, right?
Okay.
So let it be
Yeah.
this way, and now let's move it, right? Then you will realize like why I did it, why I didn't do. See, I'm not
Okay. We
printing
have done
anything,
it C2. That was C1. Okay.
right? This is C1, this is C2, right?
Yeah.
And I'm not
Yeah.
printing anything. Even if this runs, right, it will not
Yeah.
be
Yeah.
doing anything. So you will not see
Okay.
any output here. So I thought this is irrelevant as of now. So that's why I commented.
Yeah.
Okay.
Yeah. Yeah.
Okay. So now let me just print this. I will add a out statement so that I can show you the behavior. Now see this. I have an overridden method which is addition, which is taking two inputs as same as calculator. In the parent, it says a plus b, so the output should be 11. In the child, I have overridden behavior, and this time the output should be plus 10, right? So it should be 5 plus 6, 11, plus 10, 21. If I run this way, as of now, it should print 1, it should print 21. Let's see. 21, right? And if I remove this, now which version of it will, what version of code will run? The one version which is left with, which is what? The coming from the parent one, right? So let's run it. It will run what? It will print 11 this time. Okay, everyone? You're understanding, right? In the parent also and the child also, you have the same method with the same arguments, with the same data type, right? And the only purpose is that you want to just override your logic. That's it, right? So if you have that need, then you would be using what? Method overriding. Okay. So let me edit that. Okay. So, but for overriding, you need to have a parent and a child. For overloading, only a single class can also suffice. But let's move a step further. If you see this calculator class, right? You have how many methods now? You have three methods here: addition, addition, and addition. And the fourth one is this addition. And here I have overridden a method here. Let me just remove it as of now, just to avoid. So overriding this part only, right? So here, what you can do is, you see this, right? If I change this data type also, right? Float also. If I make it a float also, let's say I make it a float. Okay, what is comparing addition in scientific clashes with addition int in calculator, attempting to use incompatible type, make addition written int. What? Addition int in scientific calculator clashes with addition in calculator, attempting to use incompatible written type, make addition. Oh, okay. Okay. Okay, this is another problem. Okay, let's leave it as of now. Let me remove this method. Okay, so okay, this is something new I was trying, but let it be. So overriding, we are clear, right? I want to show that overloading, right? With overloading, it's not that it has to be in a single class. No, it can overloading can happen across the parent and child class also. So now let's say this is the method, right? This is the method, addition method. So if I try to, let's say, provide this one, and let me just add one more parameter here. Let's say string s. Okay. Let's say I'm adding this here. Now what I'll do is I will print. So I'm changing the behavior, right? I'm changing the behavior also. I'm saying value s value is s value is s here. Okay, sorry. Right. Now you can see how many methods do we have for addition, which are accessible to scientific calculator. So three are coming from the parent, which is this addition, right? And you can see we do not have a signature which matches to this. You can see addition. These are two, but there's an additional one. So it's like a new method here, right? What about these two methods? So this is also not here, right? And this also is not here. And private method you cannot access, so that is a different case altogether. So now, how many methods does the scientific calculator has with the name as addition? It has four now, right? One, two, three, and the fourth one. In this case, right? What do you call this addition method? This is also called as method overloading, not overriding. Why it is not overriding? Because the signature is not matching. So this is like you have given another behavior to your addition method, but this time that behavior is sitting in a child class. Okay, so it is not that overloading happens only in a single class. It can happen if you have a child of that class, right? You can still have an additional method or additional behavior of that method in your child, right? And that would be counted as your overloading, right? So now you can see, right? It is similar to this, right? It is same as this, that this is one method and you have three methods on top of it, right? Which is this, which you are getting inherited from your parent, right? So in total, you have four methods here. So and all these methods are with the name as addition, addition, addition. So this becomes method overloading. But we are meeting the criteria, right, of method overloading here. Why? Because the signature here, right, is different in all the cases, right? So this is called as method overloading. But remember, method overloading can also happen across the hierarchy also, parent and child. So let me remove this. Let's see this. If we go back here, right, let me remove this now. If you see C2 now, you will find four methods. Earlier you were seeing only three methods, right? You will find four methods. Addition, addition, addition. This one, the second one, right, is coming from its own copy, right? You have added a overloaded method of the addition method in the child itself, but the other three are coming from your parent. So again, you can keep on adding how many overloaded methods you want. Okay. For overriding, the method and method name and the signature of it should have matched. But in this case, the signature is not matching. So that's why it becomes method overloading. Okay. So again, going back to the original concepts. So let me write it in a different page now. So try to understand. I'm just trying to summarize what we learned. I'm saying parent. Within a parent, you have created a method. Let's say we have a method addition here, right? Addition. So this is int and int. Let's say, right? Int and int. So this is one method as of now. Let me add another method. Addition. Nothing here. So this is called as what? Overloaded method. Overloaded, right? If I add another method, addition, int, let's say int. This is not allowed because this is a duplicate method. So this is not even allowed. So it's a duplicate method. In the same class, you cannot have two methods the same name. So this is not allowed. Okay, this is not allowed. What is allowed is you can have a method again, which can have a different signature. Let's say only one variable. So this is allowed, but this will again be counted as overloaded method. So this is allowed, this is allowed, this is allowed, this is not allowed, right? But this is overloaded. Now, when we talk about overrided method, right? Overriding cannot happen in the same class. So parent class, you cannot see the thing of overriding. Overriding only happens in the case of a child class. So it's a child class. But since this is a child class, right, of a parent, of this parent, you already inherited all three methods. So you, as a child, you already have access to all three methods here, which are public in nature, right? right? So if you try to create the instance of the child at this point of time, you're still able to access how many methods? 3 methods, which are these. Now, if I create a method inside this, let's say addition again, and let's say that I want to rewrite the logic which your parent had written in the addition method. I did not like it. I want to change it. So what I'll do is I'll create the same name with the same signature here, right? Now you can see it is matching to this part. If that is the case, this is called as what? It is called as overriding. Okay, it is called as overriding. But if let's say that you created another method which does not matches to anything here, right? But with the same name you're trying to add. Let's say I added here int and float. This is called what as what? You can see this part, this complete part here, right? Is not matching to this. It is not matching to this. It is not matching to this. It is not matching to this, right? So in a way, what is happening is you added one more behavior for the addition method, and this is termed as what? Overloading. So your overloading thing, right, can happen in the same class, right? Or it can also happen across the classes if they have a parent-child relationship. Okay, and overriding can only happen in the parent-child relationship only. But in that case, the method name and the signature would also will be same, right? Okay, and for the and let's say that you try to create the instance of the child class, and try to access the addition method like this. Addition 5 6, which version of addition will run? The overridden version. Okay, and if you create the version of a parent and then child to and access the addition method of 4 3, which version will happen? Not this one. Parent does not have to have anything about child. It's all about this part. Okay, so for parent, if it runs this version of addition, it will run this part, and for a child, this will run this part. Okay, and about these methods, whoever runs this, the let's say I run addition here, right, like this. I run addition again with 5 value. I run here addition with a blank value. I edit run 5, and I run is at 2 comma 5.0. If I run this, right, so what is happening here? This method, if I run this way, right, what is getting executed? This will get executed. If I run this method here with the child thing, right, what is getting executed? This method. If I run this 5 thing, right, what is getting executed? This method. If I run this 5 here, right, what is getting executed? This method. If I run this 2 comma 5.0, what will run? This method. If I try to run this method here, right, addition 2 comma 5.0, what will happen in this case? Anyone?
It will throw the error.
Yes, it will throw the error because parent does not have the access to the child method, right?
Yeah.
Sally answered this,
Yes.
right?
Yes. Yeah.
Great,
Yeah.
great. So you're learning, right?
Yeah. Yeah.
Okay, great. So you're right. So it will throw an error. Okay, let's see this. I added what? I have added public int addition, right? So it's a different method altogether. So C2, right? Okay, let's remove this. Calculator. Calculator C1 equals to new calculator again. And if I try to do C1 dot addition, you can see, right? Only 3 methods are applicable, are accessible. For the one coming from child is not even accessible. If I do this now, 2 comma 3 comma 4.0, you can see it will start complaining. Why are you doing this? I cannot see a method inside C1, this calculator, because it has only these 3 methods or this 4th method, right? But it does not have a version like this. So it will keep throwing this error. Okay. So this is what overriding and overloading is. Okay. Okay. What else? Okay. One interesting thing. We also learned yesterday about upcasting and downcasting. Let's see what happens with the overridden method when we do upcasting and downcasting. That is a very interesting case. Okay. Let's try to use those concepts here. So now what I will do is, let's see how many methods I have. I have 3 methods here, and I have the 4th method in this part. Let me clear all this mess, and let's start creating. I will first create the method of my parent calculator. Let's C1 equals to new calculator, right? So I create this. Let me see how many methods I can access. I can access C1 dot addition, and I will add 5,6. So this is the first version coming from the parent itself. Oh, I have not added the override method, right? Let me add public int addition int a int b, right? And let's say return a plus b plus 10. Okay, so this is the overridden method. Let me write here. This is the overrided method, and above one is what? It's a overloaded method. Okay, now if I'm running c1 dot addition, which version of will run? The parent one, right? The parent version will run. So it will print what? It will print 11, whatever thing is, right? So let me say c1 dot addition again. If I use the other method again, this is coming from parent only. So 5 dot 0 and let's say 6. Does it work? It does not work. 5f. Yes, it works. Okay. Now what else? Let's say c1 dot addition, right? This part. If I do this, so this is all about parent, right? So I can access all the methods which are coming from parent. So everything is running of the parent version like this: parent, parent, and parent. So these are straightforward, right? These are straightforward. The only understanding we required was on this override method. So this is an important one. So currently, if you create the instance of the parent and assign it to a reference type of parent only, right? Then which version will run? The parent version will run, which is this, which is what we understood. Now let's create the child one. Scientific calculator, and I say SC here equals to new scientific calculator. Now let's say SC dot addition. We can see we have 4 methods here, right? Access to 4 methods. So 3. So you can see, right? Two are coming from here itself. One is the overloaded method, which is this, and this is the overridden method, and 2 are coming from your calculator part. So this method has been overridden, right? This method. Let me type here. Overridden in child class. Okay, and everything else here is the overloaded version. So how many? So for child, for this child, this does not exist anymore. What exists is this one, right? So this is one method, this is the second method, this is the third method, this is the fourth method. Fifth is not accessible because it's a private method. So 4 methods are accessible. So let me write here sc dot addition. So if I run 5,6, this is like your overridden method, and this should print your child version, and it should print the value as 21. Okay. If I run sc dot addition, this is coming from a parent. Sc dot addition, this is coming from again from your parent again. 6f comma 6. Okay, and the last one, which will come from its own version, which is this one, int a int b string s. So let's use this one. So 8 comma 9 and akhil. Okay, so we can, so till now everything is fine, right? The object which we created and the thing which we are accessing, we are able to access the ones which are really accessible there. Now let's add some complexity, which is respect to the upcast and downcast. What is upcasting? Upcasting means that you will create the instance of a child and assign it to a parent, right? So how do you do it? You do it this way. You will create the calculator, which is the parent calculator. You will say C2 here, and you will assign what? You will assign a child, which is scientific calculator. Scientific calculator. Okay. And this time I will do what? C2 dot C here. How many methods are accessible? The first one, the addition one, right, is still coming from the parent only. Okay, let's try to see this. If we use C2 dot addition float a and b, right, which is this part, again coming from parent only. So let's write here addition float this one, right? So let me say 5f comma 6. Okay, let me do one thing. Let me just keep things same. So this is parent. Let me write here also. This is coming from parent. The this part is also about 5f and 6, so that you can compare the output also. So this is also coming from parent, and this part is coming from the child part, right? Child part, and this was the overridden method, and this is the overloaded method, right? So now if I'm running this addition part, this is coming from where? Parent only, which is fine. If you see this part, this is coming from again parent only. What about the next method? The one which was overridden, which is this one. If I type here 5 comma 6, what this should print? Is it first of all coming from a child version, or it is coming from the parent version, right? And what it should really print? Should it print 21 or should it print 11? Let me just mention after this only. Parent, if it was of parent, it will print 11. If it is of child, it will print 21, right? It will do this thing. Let's answer this. Let me run this. I hope we are, oh, we are not printing this, right? Just a second. Okay. Let me add the method here as out. This, and let me say C here and C here. Okay. So we are good with this part. Copy this, and also let's have the behavior here also. This part, and here I will say CS int C equals to A plus B, and here I will print C. Okay. And for others, I don't care because I don't want to, because there is no, you will find there is no difference here. Okay. So let's try to run this. I want you to focus on this part, on this part, and this part here. Okay. Let's run this because these are the three things which will get printed here. Okay, let's see what do we get. You see this? It prints 11. First of all, let's review this. So in the first case, I said C1 dot addition. You're creating the instance of the child of the parent only and assigning to the parent. So which version of this addition will run? It's a overridden method in child class, but this time it will run what? It will run the parent version only, right? Because you're both the in both the places, parent is involved. So it will print the parent version, which is 11, 5 plus 6. If you go next, right, about the child, in the child you have overridden that method, right? And if you try to invoke that method, it would run the version of the child, which is 5 plus 6 plus 10. So it printed 21. In the last case, over here, right, this is doing upcasting. You created the instance of a child and you are assigning it to a parent. See this. If you try to run C2 dot addition now, you may think that you are trying to see what is happening here. I told you, right? Read it like this. You're saying create the instance of a child and make it behave as a parent, right? That is what we are trying to do. But in case of overridden method, what will happen in there is that parent, see, a parent would be only, I mean, let's say I have, okay, if you see this, right, if I do this thing, right, you can see if I try to access this method, which is an extra method inside this, can I access it? C2 dot addition. You will find that I cannot even access this. This is something which we learned yesterday. 5 comma 6 5 comma 6 comma, let's say Akhil, right? If I try to run this, you can see I'm creating the instance of the child class, right? So if I would have assigned it to a reference variable of child, right, I would have been able to access this method like I was doing earlier, right, up in the above case. But as soon as you do this, right, create the instance of a child and expect it to behave like a parent by doing this, by doing the upcasting operation, right? So the first implication which you'll have is that all the additional methods which you may have in the child does not become accessible. You can see it throws an error. So this method is not accessible, right? Let me comment this. What about this method which you have overridden? In this case, right, your parent will not be able to use his own version. He will be only able to run the version which is coming from your child. Okay, this is this one which I'm talking about. Okay, so here what will run? The child version will run. So this is one additional. This is the case which you have to remember, right? If you try to do upcasting, right, and you have a overridden method, right? So by using the parent, If you invoke that method, right, which version will run? The child version will run. Okay, you can see 21 here. Let me run it again. It will print what? 11, 21, 21. You can see here, right? It is printing the child version. Okay. Now let's perform the downcasting also. If I perform downcasting, how do you perform downcasting? You just convert this C2 now back to a child. This one, right? How to do it? You will do something like this. Scientific SC equals to this. Scientific calculator, and let's say C2. Okay, I have to give it a different name, SC2. And let's just try to access this method, SC2. You see, let's try to see this method. You can see all 4 methods are accessible, right? Because now it is entirely behaving as the child only. So if I run this now and I provide here 5, 6, right? You can see it will behave as what? Child only. Let's run this. Let me comment other things. This is unnecessarily adding some may add some confusion. Okay, so if you create an instance of a parent and assign it to a parent, and you try to access the overridden method, right? Which version will run? Parent version. If you create the instance of a child and assign it to a child only, and try to access the overridden method, which version will run? The child version. Okay, in the above case, it was parent. It is here child. If you try to create the instance of a child and assign it to a parent, which version of the overridden method will run? The child version. This is the case which you have to remember. Okay, and here, if you do a downcasting, right, and you're doing this, which version will run? Child. Why? What is C2? C2 is this thing, right? So let me copy this. So it means that if I try to write this as this also, let me just move it to the right hand side. Like, let me make it S3. If I do this thing, right, C2 is what? C2 is equal to this part, right? So it means that I can replace it with this value. Now you can see you are creating the instance of a child and assigning it to a child. Which version of the method will run? Obviously the child version, right? Because both the sides, the child version, the child thing is mentioned, right? So downcasting is very simple. You have to understand which version will run. The child version will run, right? And why? Because you can just simply put, like in our case, right? In our school days, college days, we just replace the mathematical equations with those variables and we just check there, right? Similarly, you can check here. You just copied what it had, right? And then things will start making sense. And here, this is redundant, right? This part is redundant, and that is what it says. Casting new is redundant. So it is as good as that you don't even write this. So what you can do is you can simply do this part. Remove this and make it as SC4. Right? So all 3 things are same here, right? Just different ways of writing. Again, we discussed this yesterday only, but I'm just pointing it again. The only case which you have to remember in the case of polymorphism is that if you have a parent-child relationship and you try to create the instance of a child and assign it to a parent, and you try to access the overridden method, which version will run? The child version will run. Okay, that is the only takeaway from this point. Okay, so this is about overloading and overriding. Again, overloading happens in the same class. You can have methods with the same name but with the different signatures. With respect to overriding, it happens across the classes, which is parent and child. You will try to keep the name as same, the signature as same, right? And if you try to, and we talk about this upcasting thing, if you try to get the instance of a parent, a instance of a child and assign it to a parent, and try to access that overridden method, which method will run? The overridden method will run of the child. Okay. So this is all about polymorphism, right? You can see a single method can behave differently based on the inputs it receives, right? So if you provide 2 inputs, it behaves differently. If you provide no inputs, it behaves differently. If you provide 3 inputs of 3 different data types, it behaves differently. So this is referring, so that is the example which I tried to give you, right, of a man. So if you provide some inputs to it, it behaves differently, right? Accordingly, this is what we are trying to replicate in the Java program. using the OOPS concept, what we discussed. Okay. Okay. What else? I think for polymorphism we are good, and this is what you have to remember. The data. Okay, and one last part, right? So you have to understand, right? What really matters is the name of the method and the parameters which it is accepting. You can still modify the return type. You can still modify the access modifier, right? It is like an optional. It's like an optional thing. You, if you want to choose it, you can choose to change this. But the core rule of overloading, right, or overriding is that what matters is the name of the method and the signature of it. Okay. If you follow those rules accordingly, overloaded and overridden behavior will be you'll be able to see. Okay, great. So we are done with polymorphism. So we have covered one more OOPS concept, which is polymorphism apart from inheritance, right? And these are two very vital things. One last thing for today, right? I wanted to cover is the small thing, which is encapsulation. Encapsulation means you can understand that if you what is encapsulation? Encapsulation, you can remember encapsulation with the word as data hiding. Okay, just remember encapsulation as data hiding. Let me write it here. So we have covered two concepts of OOPS till now. OOPS, we covered inheritance. We understood that there is a parent-child relationship here, right? A parent-child relationship. So your child inherits what your parent had. Okay, and we covered all the rules. The second part we covered is polymorphism. So remember with the word as overloading and overriding, but what it really means is it means one thing. I mean something which can behave as many forms, right? One thing which can have many forms. One thing which can have many forms, right? Poly means many, morphism means shape, right? And here the concepts are overloading and overriding. The third thing which I'm saying is encapsulation. Encapsulation, just remember this with the words as data hiding. Okay, and let me also, how data hiding works. We have already learned this, right? How do you, let's say that I have a class, let's say car, right? I have a class car, and I have the engine name, let's say engine name here, right? The string value is engine name. Now what it means is that when I say data hiding, right, it is really not data hiding, it is like control on data, right? Data controlling, let me say data hiding or data controlling. What it does mean is that you want to have the control on your data, and you don't want that everyone in the world should have access to your data. So how to control that thing? We have learned that part. It will be done through what? Your access modifier. If you make your this variable as private, no one in the world can access your variable now, right? Because who can access it? Only inside your car class can be, this thing can be accessed. So no one outside the car class can access it. So for the outside world, this variable does not even exist. And if it does not exist, no one can even modify this value, at least by directly accessing this variable. But because if you try to do something like this, car c1 equals to new car here, right? And if you do c1 dot engine name, if you try to get this right, it will throw an error. If you do c1 dot engine name equals to, let's say, Ferrari, it will say you cannot access it. So how can you set the value? So this will also be not allowed. So now you can see you cannot get or you cannot set here. So both operations are blocked because of the one thing that you marked your variable as private. But we still need to set the values. We still need to get the values, right? There should be some way, but not directly through the variable name. We do not want anyone in the world to access our variable directly. That is the only part, right? We don't want that control to be passed on to someone. We want that control to be with the car only, with that specific class only. So how to make someone access this variable now? We will do what? We will create one getter method and one setter method. How do you do it? Very simple. If you want to set the values, so it means that you want to set the values of this engine name, right? What you will do is you will create a method with the public modifier so that someone in outside world can access it. So you will say public and you want to set the value, right? So when you want to set the values, you do not want to return something, right, from it. So what you will do, you will write here void, because you don't want to return, you are just setting the value. So you will say the name as set engine name. Again, this is a nomenclature, right? You can use just set keyword, and whatever variable name is, just use that thing, engine name. And then here accept one input, let's say name, right? And inside this method you have to do only one thing, engine name equals to name. And now the outside world cannot access it through this way, right? But what they can do is they can say c1 dot set engine name and provide a value as Ferrari, right? Now your engine name is will be set to Ferrari because of this operation, right? You provided Ferrari here, right? So Ferrari came here, and you are assigning that Ferrari to engine name. What is engine name? This one. So you're able to set the value here, but not directly through a method. You're controlling it, right? Similarly, if you want to get the value, what you will do? Now you want to get the value, so your method has to return something, right? What is the data type of it? String. So you will have a data type as string, and you will say get engine name, and you will not. There is no need to accept any inputs, right? Because your value is already there with the class. You just need to return it. So what you will do is you will simply come here, return statement, and do engine name, right? So this is what encapsulation is. You're controlling your data of the class by providing the getters and setters, and by making your variable as private. Any question on this part? I think this is very straightforward, and it should be very clear on this. Other, this is clear, right? You're not audible if you're saying something. If you can type or something, right? Ashok, this is clear, right? I think you were asking about getters and setters, right? Ashok,
Yes, Akhil, it's clear.
it's clear, right? Okay, great.
Yeah.
Sally, is this clear to you?
Yeah, yeah.
Okay. Rafaelia, I think this is clear to you, right? And Sudhakar, just one?
Yeah, it's clear. Yeah.
Okay. Atul, it's clear for you, right?
Only one query over
Yes,
here.
Akhil.
Inside
Great.
that particular function, no, why you give engine name is equal to name?
Okay. If I don't do this, right? Tell me, like, what is happening with the engine name here, right? It is not set yet. My idea of this method is that I want to accept an input for my user, which they will provide, like here, right? They provided Ferrari. I want to use this value to set my engine name, right? How will I do it here? Tell me.
Okay, so you are directly initializing it in that particular method only.
Yes,
Okay.
right? But you have to understand this way, like what is the advantage of this? Now, advantage is that you can have a logic inside your method. Let's say that you want to check your data, right? Whoever is setting, right? Here I'm not doing all that logic, but let's say you want to verify that really someone provided a value. See, let me show you in the code also. I was thinking I can avoid it, but let's do it. Let
Is
me.
is it not needed for us to use this keyword?
You can use this keyword also. Okay. I did not purposefully edit this keyword because we have not talked about this in a detail. But although we have already seen, right? But yes, you're right. We can do it. I'll show you both the things. Okay. But I will not explain this keyword today. I will leave it for some other class. But let me say car here, car, and let me close all the other things very quickly. Let's do it. Okay. So public class car, and let me create a variable. Now see this. If I to here string engine name, right? If I do this, and let's say I make it as public, let's say I make it as public, right? And if I go and create another class here, demo car, whatever that is, uh, demo car class. If I do this and I add a main method, and if I here, right, I try to do car c1 equals to new car, right? Now since my car Now see here, right? My car over here, right, has a variable, but the type, the access modifier is what? Public. So if I do c1 dot engine name, right, it does not complain. I can simply write whatever I want. I can write Ferrari. I can write even cycle. You see, there is no control. If I do this right, and if I try to print this value, c1 dot engine name, right, you can see here what I'm doing is I'm setting. This is a set operation, and this is what? This is a get operation. You're getting the value from the class. If you do this right, no one will complain, and you are directly able to set to the variable itself. See here in the output, cycle, right? It's a car, and you're providing the name as cycle. Why? Because you marked your variable as public. So anyone in the world can access and change the value. Okay. Let's say I don't want to do it. I really don't want that someone can just directly access my variable like this. So for that, what I have to do is, first thing is I will have to make my variable as private. As soon as I make it very private, right, no one in the world can access it. You can see it starts complaining. But now the next problem is that how will I set the value from the outside world? How will I get the value of engine name from the outside world? Because I still need them, right? So for that, the solution is you will create two methods. The first method would be public again, which is to set the values. So when you are setting, right, there is no need to return anything from it. So I'm using void. So let's say set engine name. Okay. And here I will accept one parameter from the user. I will say provide me the name here, right? And whatever name I'm receiving, I want to set to this engine name. So what I'll do, I'll just simply say engine name equals to name here. Okay, and it works, right? And similarly, so this will be able to set the values. And if I want to get the values, again, I will have to make my variable, my method is public, and I will do what? Return, it's a string value, right? Engine name is string. So if I have to return a string value only, so a string here, and I will say get engine name, right? And I will do what? I will say return engine name. Okay. Now this is not working, so let me comment this out. What I have to do now is I would have to access it like this: c1 dot set engine name, and I can provide here Ferrari. Okay, Ferrari. And similarly, I can do what? I can say c1 dot get name engine name like this, and I can just print this out. Right, let me run this. You will see Ferrari being printed now, right? So this is what the encapsulation is. You are trying to have a control on data. You are the one who is deciding who can access, who cannot access, or what value can be set. Let's say someone provided a cycle value, right? Earlier you did not have an option, right? If someone was able to cite a cycle value, you would be setting it, right? He would be able to do it. But now, since has to go through this method, I can add a logic here. I will write if name equals to cycle. Let me write equals ignore case as cycle, right? If someone has provided cycle, print out you are not meant to use car, simply stick to cycling. Okay, stick to cycling, right? But if someone else provides something else, right, then only I want my engine name to be set. Okay, you see, right, now I have a control based on the input, right? I can have my logic here. If I provide cycle here, right, let's run this. What will the value which will be getting set? Let's run this. I'm trying to set the value cycle. None, right? Now I have a control. Now I can control the logic. Earlier it was not the case. Does everyone understand this part, right? Okay, great. Last question, which I think this one asked about this one, right? You, yes, you can do it. This, just use this, but this also works, right? If I run it again, so this dot engine name or engine name will work. This dot engine name will make more sense if I've used this if I've not used name, but I've used engine name only. Okay, then you would have understood the real importance. So if I use engine name here, and engine name here, right? If you do this now without using this, now nothing will happen. See this. If I run this, let me not provide cycle, let me provide here Maruti here. Now tell me what should I see as the output here? Should it be Maruti? Should it be null, or should it be something else?
Null.
Right, it would be null. Why null? I'm not providing cycle here, so this if block will not run. This if block is not running. It is going in this else block, and it is really running this line. But what is happening here? See, I told you my local variable name is also engine name, and my instance variable name is also engine name. If my program gets that conflict, that okay, someone is asking engine name, which engine name they are referring to. So if you are setting in a method and it has a local method with the same name, that will take precedence. So what will happen here is this engine name is referring to this local variable only, and this is also referring to this only. So what is happening here? You are just reassigning the value to your local variable again. But what you have to really do, you wanted to set the value of this engine name, which is your instance variable, right? And why this is happening? Because your local variable and your instance variable have the same name. So if that is the case, what you should do is to refer to your instance variable, right? Use this here. And now the issue would be resolved. If I run it now, you can see, right? I have not made any other change. I've just added this. And now you will not see null. You will see Maruti. Because this keyword will always refer to your instance variables. Okay? Your instance. You can see Maruti now. Right, Jaswant?
Understood.
Okay, great. Great. Okay, I think we are good for today. I do not have anything else. So we are done with all three the three concepts, which are inheritance, polymorphism, and the encapsulation. Abstraction is another good concept, which will require some new additional knowledge, right? So I think anyhow we don't have a class tomorrow, right? So next 3 days, I would suggest everyone, right, to brush up with everything we have covered till now, right? You have 3 days now. Even if you try to utilize today also 1 or 2 hours, you can get some more about it, right? So please utilize these 3 days well enough, right, to go through all the concepts we have learned till now. Because starting next week, right, we have to cover that part, and we have to start the collection frameworks, which is the starting point, of your advanced Java. Okay, so please buckle up your seats. Next week, we are going to raise the level. Okay, but again, it's not that we are going in a harder, something which is very hard to understand. No, I'm not saying that. It's just that we are going to learn something new, which will require some new additional information to be added here, right? So that you can start understanding more. Okay, so I think we are good for today, right? Let's meet on Monday. But again, if anyone has a doubt thing, right, please add it on your Discord, in our Discord channel. If those doubts can be solved there, fine. If not, we will have a doubt session on Saturday, 5:30 p.m. in the evening. Okay, but it will only happen if we have doubts. Okay, otherwise we'll have a class on Monday itself. Right, everyone? Great. I think we are good for today. Thank you so much. Good night. Take care and happy weekend. Happy long weekend. If all who all have them. I have a leave tomorrow actually. So for me, it's a long weekend. Yep. Thank you. Take
Thank
care.
you. Goodbye.
Great. Enjoy, Akhil. Bye.
Thank you. Bye. Bye. Take care. Take care, everyone. Bye.